Alright, this is part 2 of our lesson on solving systems of polynomials. Let's start off with number 3, where we will take a look at a cubic and a linear function. So as I mentioned, this is a cubic function, obviously, and this is going to be a straight line, but we can be more specific than that and say that this is going to be a horizontal line. Alright, y equals a number is just going to be a horizontal line. So in general, a cubic function is doing this type of a thing. Okay, and then we're going to be dealing with a horizontal line, which in general will be doing this type of thing. Alright, so we're looking for up to 3 solutions, but we'll see how it goes when we actually solve it out. So definitely substitution is going to be the way to go for this problem, so let's do that. Alright, so looking at the first function, we have x to the third power minus 2x squared minus 3x plus 2, and it says equals 0, but really that should have been y equals. Alright, so that was kind of a mistake. I'll probably fix that before you even see it. Okay, this should be y equals this, not equals 0 at this point. So anyway, what did I say? So this should be y equals x to the third power minus 2x squared minus 3x plus 2. And then over here we have y equals 2. So y equals all of this. So I'm really going to take this entire thing and I'm going to substitute it for y right here. So this is going to become x to the third power minus 2x squared minus 3x plus 2 equals 2. Alright, here's the equal 2 part. I'm just copying that down. So to solve this, we need to get 0 over here. So let's definitely subtract 2 from both sides. But you'll notice that both of these 2's wind up canceling each other out. Okay, so that's going to give us x to the third power minus 2x squared minus 3x equals 0. Alright, so let's go ahead and just try to factor this and see how far we get. So the first thing we'll do as we try to factor this is the first step of factoring is GCF. So I see a common factor of x. All of these have x's, so I'm definitely going to pull that out. And then that's going to leave behind whatever it leaves behind. X squared minus 2x minus 3. Now this trinomial looks like it might be factorable. So let's give it a try, but in the meantime, this x is still around. Don't forget about it. And let's try to factor this and see what we can do. X squared would be x times x. 3 can only factor as 3 times 1. And then we remember our inner, outer, middle, right? Inner plus outer must equal the middle. So inner right now I have 3x. Outer I have 1x. I'm trying to get a middle of negative 2. So if I had a negative 3 and a positive 1, that would give me negative 2. So there's my negative 3, there's my positive 1. Will that give me negative 3? Yes, negative times a positive is a negative. So this is now factored correctly. Okay, so to solve it though, we need to set each of these factors equal to 0. So let's do that. Okay, all 3 of these factors can be set equal to 0. So over here I'm going to have x equals 0. Alright, that's 1x value. If I do x minus 3 equals 0, I'm going to wind up adding 3 to both sides. So that gives me x equals 3. It's a second x value. And over here, if I set x plus 1 equals 0, I will subtract 1. So I get x equals negative 1. So I have negative 1, 0, and 3. Let's make a t-chart. Okay, here's my t-chart. XY chart. Okay, so I have 3 x values to play with. I have negative 1, 0, and 3. We need the y values to go with it. But hey guys, let's use this equation for y, because that's the simplest one to deal with, isn't it? Y equals 2. Well, that means y equals 2 no matter what. 2, 2, 2. So right away we get our 3 solutions. Okay, our 3 solutions are negative 1 comma 2, 0 comma 2, and 3 comma 2. Okay, we were expecting 3 solutions, up to 3 solutions. Let's go ahead and take a quick look at an electronic graph so we can see what really was happening. Alright, there's the first equation, and the second equation is just y equals 2. So y equals 2, and enter. Okay, so there's a nice image of what we're dealing with, and there's our cubic, alright, and our y equals 2, of course, was that horizontal line, and sure enough, we have our 3 points of intersection. Okay, so that one was pretty close to our sort of guess right at the beginning. Alright, so that's number 3. Let's go ahead and take a look at number 4. Hold on, this line's bothering me. OCD! Alright, let's look at number 4. What we have here is a cubic and a line. Alright, so this is cubic and this is linear. Okay, so again, a cubic is doing this type of thing in general, and then we have a linear equation. It's not horizontal this time, it's a slanted line, but we are still expecting up to 3 solutions depending on exactly how they interact, and we'll cross that bridge when we come to it. Alright, let's get ready for substitution. So the first equation I have is y equals x to the third power minus 3x. Alright, and then I have y equals x. So for substitution, I'm going to take this and substitute it for y in the other equation. So that's going to give me x to the third power minus 3x equals x. Just brought that down. So I need to get 0 over here so I can factor or whatever I'm going to do. So I'm definitely going to subtract x from both sides. So these cancel. These are like terms though, so I will put these together, and that's going to give me x to the third power minus 4x, okay, because it's like a negative 1, equals 0. Now I need to factor this, but the first step of factoring is to pull out the GCF. Alright, there's a common factor of x, so let's definitely pull that out. And what does that leave behind but x squared minus 4? Very interesting. Okay, so bringing down this x, I recognize that the x squared minus 4 is further factorable because this is the difference of 2 squares. So x plus 2, x minus 2. Okay, in a situation like this, you set all of the factors equal to 0. So you do x equals 0, so that's one x value. And then you do x plus 2 equals 0, Subtracting 2 from both sides gives you x equals negative 2. Okay, and then x minus 2 equals 0. Adding 2 to both sides gives me x equals 2. So these are our 3 x values. Now we just need the y values that go with them. Okay, so let's set up our t-chart over here. Okay, so x, y, 3 x values. Alright, what did I have? Negative 2, 0, and 2. So there's negative 2, there's 0, and there's 2. Y equals x is the simplest equation to use. So let's do that. Y equals x. OCD, OCD, OCD. Okay, so if y equals x, then that means in this case, y equals negative 2. Okay, so I got negative 2. If y equals x, then that means similarly, this will be 0 and this will be 2. Okay, y equals x, they're the same. Boom, 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 boom. Okay, so that's it. That gives me my 3 solutions. I've got negative 2 comma negative 2. I've got 0 comma 0. And I've got 2 comma 2. Alright, 3 points of intersection. Okay, so we were expecting something like this, but let's go ahead and take a quick peek at Wolfram Alpha. I always like to get a view from an electronic graph. Alright, our first equation was y equals x to the 3rd power minus 3x. Okay, and our second equation was y equals x. Enter. Alright, just scrolling down. Okay, there's a nice view of what happened. So we have our intersection points here, here, and here. Alright, so that's what really happened. And my goodness, that's just almost exactly what we predicted in our initial guess. So we have this all figured out. Alright, I'm going to go ahead and end this video here. And let's see, in our 3rd and final video, I will do problem number 5. Alright, a quadratic and a linear. Alright, it's a parabola and a line. And problem number 6, another parabola and another line. Alright, see you on the next video, people.